In this video I'm going to be solving this Gaussian elimination, this system of simultaneous equations using Gaussian elimination. So the first thing I've done was to rewrite this system of simultaneous equations as a matrix in this augmented matrix, where on the right hand side of this line I have the right hand side of the equal sign. Okay, so the first step, this element 1 is going to be our pivot, and we're going to use that element to get zeros here and here. So on the first column, second row, and third row. And I'm going to convert here. So the first thing we're going to do is minus row 1 plus row 2 to get a 0 in position 2, 1 here. So the first row doesn't change, and the second row will change following this operation. So minus 1 plus 1, 0, minus 2 plus 4, 2, minus 1, minus 1, minus 2, and minus 3 plus 2, minus 1. Now on the third row we're going to change it as well to get a 0 in this position here. So we're going to be doing minus 2, 2 is the number we want to cancel, bring it out, change the sign, multiply times the pivot, the row with the pivot, which is row 1, and add it back to our third row. So minus 2 plus 2, 0, minus 2 times 2 is minus 4, plus 1, minus 3, minus 2, minus 2, minus 4, and minus 2 times 3 is minus 6, plus 4, minus 2. Our first column is finished. We have the 2 zeros we need below the diagonal, so we move into the second column, and for the second column this element is going to be our pivot. So before we start getting zeros, we're going to make that element into a 1 just to make our life easier. So we're going to divide row 2 by 2. Row 1 is not going to change. Row 2 becomes 0, 1, minus 1, and minus a half. And we can rewrite row 3. Now we're going to use that 1 that we just got is our new pivot. We're going to use it to get a 0 down here below the diagonal. So the operation is going to be 3 times row 2 plus row 3. It's going to get our new row 3. Rows 1 and 2 don't change. And the new row 3 is going to be 3 times 0 plus 0 is 0. We're not destroying any previous work. 3 times 1 minus 3 is 0. 3 times minus 1 is minus 3. Minus 4 is minus 7. And 3 times minus a half is minus 3 half. Minus 2 is minus 7 over 2. Now at this point we can see that all the values below the diagonal are 0, and we're finished with the elimination. Now we're going to solve for z and use back substitution to get y and x. So from the last row, I'm going to just put an arrow here, we know that minus 7z equals minus 7 over 2, so z is equal to 0.5. Now we're going to the second row, and we know that, I'm going to put a line here, y minus z, which is 0.5, equals minus a half. So y is equal to minus a half plus a half, so it's equal to 0. And then we go into the top row and we solve for x, so x plus 2 times y, but y is 0, plus z, which is 0.5, equals 3.